Module 8, System Design Principles. Objectives. At the end of the module, you should be able to understand the importance of software design in the software development lifecycle, explain the design aspect of a software, and explain the design concept involved in the good design. Software design. Ano nga ba ang software design? Software design is a phase in a software engineering in which a blueprint is developed to serve as a base for constructing the software system. IEEE defines software designs as both a process of defining the architecture, components, interfaces, and other characteristics of a system or a component, and the result of the process. In the design phase, many critical and strategic decisions are made to achieve the desired functionality and quality of the system. These decisions are taken into account to successfully develop the software and carry out its maintenance in a way that the quality of the end product is improved. In short, yung software design is like a blueprint. Parang blueprint ng bahay. Siyempre, pag gagawa ka ng bahay, kailangan mo ng blueprint. Paplanuhin mo lahat. Bawat parte, kwarto, sala, kusina, kung paano mo lalagay ng poste, kung paano mo lalagay yung bubong, kung ano-ano yung mga materials, yun yung blueprint. Ganon din sa software design. Sa paggawa ng software, kailangan mo syempre may sarili ka ring blueprint. Doon na lahat yung laman. Kung ano yung parte ng software, kung paano mo gagawin, nandun na lahat. So, in this module, we will look into the different principles involved in the design phase. The next module will handle the different aspects of design phase.
In designing a software project, there are 4 major aspects of the system that we need to address, which are the data design, architectural design, procedural design, and the interface design, which I will discuss in this report. Let's begin with the data design. It involves transforming the data model specified during the analysis phase into a representation ready for implementation. We design how the data of our application will logically look like when implemented, so we use a data structure to do it. Data structure samples are below. Data design is considered the most important component of the development process since it dictates the procedural structure and complexity of the system. So, basically, it is the first design activity which results in less complex, modular, and efficient program structure. Next is the architectural design. We need to work with an overall architectural design which shows the control relationship between major components of the system. It represents the design of the entire software. For example is that when an architect is about to build a house, they have to present an overall architectural design first, including a sketch of a house, a floor plan, and after deciding on this is the detail of the design. Next is the procedural design. After defining the data and architectural design, we can now establish the algorithmic detail of our system. It defines the algorithms for each of the functions that need to be provided by the system. These algorithms can be specified using a pseudocode, flowchart, and a diagram. Last is the interface design. It establishes the layout of the interface and the various interactions of the user with the system. The user interface may be considered to be the one of the most important component of the system because an efficient system without a user-accepted interface cannot be considered a successful system.
The design phase partitions the software into individual components called modules. There are several issues that need to be addressed during software design with regards to this partitioning into different modules. In designing a software system, it is also necessary for us to be familiar with the tools that we can use to partition the system into modules. The expected characteristic that the modules of system must possess. Tools. Abstraction. Specification of the software system is at the highest level of abstraction. During software design, we slowly integrate more detail into our specification until we obtain the lowest level of abstraction of the software system which must ready for implementation. As the level of abstraction becomes lower, more data and function need to be defined.
Module 8, Stepwise Refinement. So first, ano po ba yung stepwise refinement? Ito po yung process ng paghahati-hati ng problem into a series of steps. So kapag tapos mo na siya hatiin into steps, gaya dito, step 1, step 2, step 3. I-breakdown mo naman siya into a series of sub-steps. Kagaya dito na, dito po yung 1.1, 1.2, and then sa step 2, hinati natin siya ulit, naging 2.1, 2.2, then sa step 3, 3.1, 3.2. So hanggang sa palit ng palit yung gagawin mo. So sa example natin dito, hinati lang natin siya sa kakaunti, pero pwede mo siyang dagdagan as many as your program requires. Depende sa logic ng program na ginagawa mo at kung anong klase ng program ba yung sinusubukan mong solve. Example natin is kung paano ba gumawa ng cup of tea. So dito, hinati ko yung process niya into 4 parts. Siyempre, first part is yung pagpapakulo ng tubig, then yung pagpe-prepare ng cups, pag-brew ng mismong tea, then yung pinakahuli, yung pagsaserve ng tsaa. Bale kung sa chart natin siya titingnan, sila yung nasa pinakataas. Sila yung general algorithm natin. Sila yung step 1, step 2, step 3. Ngayon, kung meron ka ng steps na ganyan, i-breakdown mo naman siya into sub-steps naman. So, di ko na siya iisa-isahin, pero tingnan natin kung ano ba laman ng nasa boil the water. So, makikita natin dito na yung boil the water na step ay meron pang 3 sub-steps. Yung pag-fill ng kettle, yung pagbubukas ng kettle, at paghihintay na kumulo yung tubig. So, ano ba ibig sabihin ng pag-fill ng tubig sa kettle? Ano ba yung mga sub-steps pa nakasunod niya? Kailangan muna natin i-check kung may tubig pa ba or enough ba yung tubig sa loob ng kettle. So kung enough na siya at pwede na siyang i-boil, hindi niya nadadaanan yung iba pang sub-steps. Magpo-proceed na siya sa next na main sub-step. So kung hindi at kulang pa yung tubig, next step is pagbubukas ng gripo or pwede rin yung dispenser. Hanggang sa hihintayin mo siya mapuno. Tapos papatayin mo na kung puno na yung kettle at yung last, ilalagay mo na ulit yung kettle sa socket or dun sa pinakalagayan ng kettle para ma-on mo na rin at mapainitan mo na siya. Ganun lang siya pag sinabing stepwise refinement. Basically, magsisimula muna tayo sa pinakataas, dun sa main problem, mabibigyan natin ng solution. Then, hahatiin lang natin siya into steps. So, tingnan naman natin kung ano yung magiging itsura niya kapag in-apply naman sa code. Isa sa mga way para gawin ito is to break it down into an individual function and procedures. So, ayan. Yung nasa pinakataas dito is yung first step natin. Siyempre, yung boil the water procedure, prepare the cups, yung brew the tea, and then lastly, yung serve the tea procedure. Yan yung mga main functions. So sa loob niyan nakalagay yung mga sub-functions natin o yung tinatawag nating sub-steps kanina. Kung titingnan natin itong next level, meron tayo ditong mag-check kung may tubig ba yung kettle o wala. So kung wala, pupunta siya dun sa fill the kettle function. So after naman yan, if okay na, sa kanya i-on yung kettle hanggang uminit siya sa tamang temperature na kailangan. So sa sub-steps na to, meron pang isang sub-steps sa fill the kettle. Dito naman, makikita natin kung paano ba yung step ng paglalagay ng tubig. Dito yung pagbubukas ng gripo, then some logic, yan, sa water level, kung enough na ba yung tubig. Then after nun, papatayin niya na yung gripo, then punta sa socket, and then isasaksak niya na yung kettle. So, ganun din dito sa sub-steps natin, sa main functions. So, after nung sa boil the water, pupunta naman siya sa prepare the cups. So, ganun din, meron din siyang mga sub-steps sa loob hanggang sa matapos yung process, hanggang sa mapunta na sa brew the tea, and then lastly, sa serve the tea. So, ganun, So basically, ganyan lang nagwo-work yung stepwise procedure. I-breakdown mo lang siya into a series of sub-steps hanggang sa palit ng paliit at ma-solve na yung problem. So yan, thank you sa pakikinig.
Modularity. The software system is subdivided into various components called modules. The effectiveness of this endeavor reduces the complexity of the whole software system by addressing each module separately and just combining the individual modules together as a whole. Properties of modularity system. Each module is a well-defined system that can be used with other applications. Each module has a single specific purpose. Module can be separately compiled and stored in library. Module can use other module. Module should be easier to use than to build. Module are simpler from outside than inside. Modularity does enhance the clarity of design, which in turn to ease coding, testing, debugging, documenting, and maintenance of the system. Effective design method to develop a modular system. Modular decomposability. The overall complexity of the program will get reduced if the design provides a systematic mechanism to decompose the problem into sub-problems, and will also lead to an efficient modular design. Modular composability. If a design method involves using the existing design components while creating a new system, it will lead to a solution that does not reinvent the wheel. Modular understandability. If a module can be understood as a separate standalone unit without referring to other modules, it will be easier to build and edit. Modular continuity. If a module in one module does not require changing all the modules involved in the system, the impact of change in the side effects get minimized. Data structure. Data structures are abstract structures organized in particular way that are used to organize data and provide various operations upon it. Known data structures: array, structure, class, set, hash table, graph. Data structure has two branches, the primitive and non-primitive data structure. Non-primitive is divided into two parts, the linear and non-linear. Linear has static and dynamic. The array is covered by static, and the linked list, stack, queue is in dynamic, while non-linear has tree and graphs. Software producer. Two design documents describe the same system but in different way because of the different audience for the document. Information hiding. Decide what design decisions are likely to change and which are likely to be stable. Put each design decision likely to change into a module. Ensure that the client of a module depend only the stable interface, not the implementation. Hiding design decision. Information hiding is not just about data representation. It is also about data representation, platform, input-output format, user interface, and algorithm.
Ako nga pala si Rhyan Kim Bulado, base IT 3B. Functional independence. When abstraction, modularity, and information hiding are adopted, we are design module with functional independence. This concept promotes function with one single task being performed and minimal interaction among themselves. Functional independence is important since it allowed independent development of the respective modules by different members of the development team and simplified interface between them. They are also easier to test and maintain. Thus, it's considered the essence of good design. So, ito yung meaning ng functional independence. Functional independence in software engineering means that when a module focuses on a single task, it should be able to accomplish it with very little interaction with another module. In software engineering, if a module is functionally independent of other module, then it means it has high cohesion and low coupling. So ang ibig sabihin ng function independence ay dapat sa isang kumpanya may ito yung example ko. Halimbawa lang sa isang kumpanya may isang team member na kunwari, subtraction module. Yun yung topic na gagawin nyo. Bali naka-assign sa inyo. So, paano nyo ito gagawin? So, bago kayo pumasok sa isang kumpanya, dapat meron kayong kakayahan na maipakita at kailangan mong tiyakin na ikaw at yung mga membro mong design na isang proyekto gamit ang subtraction module. So, yun nga. Kailangan mo siyang tiyakin at ma-organize kasama yung mga kagrupo mo. So, sa subtraction module, paunlarin mong paisa-isa, dapat gagampanan na at nakatalagang gawain. Dapat magawa mo yung gawain sa isang module. At dapat wala itong kaugnay sa iba pang module na inyong ginagawa para hindi ito makadistorbo. Ayan. Dapat wala kang ginagawa ibang module. Dapat yun lang yung ginagawa mo para focus lang talaga doon. At para malinaw ang ibig sabihin ko, ay dapat nakafocus yan. Focus ka na talaga sa ginagawa mo. At kung sino man sa inyo ang mga kamembro mo na mayroong idea, dapat pahintulutan mo siyang gawin ito at higit sa lahat, huwag kayong maggawa na hindi related sa ginagawa yung module. Yan. Yun yung ibig sabihin. Next, cohesion. Cohesion is the characteristics of module if each one exhibit functional independence over other modules. A cohesive module performs a single task, requiring minimal interaction with the other modules. This is a natural effect of the implementation of information hiding. When we apply information hiding, we will naturally come up with cohesive modules since we limit the interaction of each module with the other modules. Our goal is to obtain high cohesion and redesign if low cohesion is found. Meaning ng cohesion, so, in computer programming, cohesion refers to the degree to which the elements inside a module belongs together. Modules with high cohesion tend to be preferable because high cohesion is associated with several desirable traits of software including robustness, reliability, usability, and understandability. So, Ang sa cohesion lang, summary ko, pagkakaintindi ko sa cohesion, kailangan ang laman ng isang module, meron siyang high and low cohesion. So, paano yung high cohesion? Yung high, i-maintain mo na lang yun. Tapos yung low, babaguhin mo siya. Parang may idadagdag ka or ibabawas doon para maayos yung isang module. Yan lang. Tapos, yan nga. Ito yung example ng module cohesion. So, in computer programming, cohesion defines the degree to which the element of module belongs together. Thus, cohesion measures the strength of relationship between pieces of functionality within a given module. Yan. Ito yung example ng module strength. So, ibig sabihin, yung nasa taas, yun yung high cohesion. Tapos, yung tatlong nasa baba, yan yung low cohesion. Yan, ito yung mga types ng modules cohesion. Types of module cohesion. Yan, yung number 1, functional cohesion. And number 2, sequential cohesion. Number 3, communication cohesion. Number 4, procedural cohesion. Number 5, temporal cohesion. Number 6, logical cohesion. Number 7, coincidental cohesion. So, ibig sabihin ng arrow na nakataas, yung pang-una yung best, tapos yung worst, yung pinakababa. So, anong ibig sabihin ng mga yan? So, yung number 1, functional cohesion. Functional cohesion is said to exist if the different elements of a module cooperate to achieve a single function. Yan. Ang ibig sabihin daw ng number 1, na exist, bali, meron siyang na-exist, di ba? Sabihin nun, napanatili niya. Yeah, ang pagkakaiba ng mga elemento sa isang module. So, na-achieve niya. Yung number 1, yung functional cohesion. So, yung number 2 naman, sequential cohesion. A module is said to be possess sequential cohesion if the element of the module form the components of the sequence, where the output from one component of the sequence is input to the next. Yan yan. Siya yung, number 2, siya yung maglilipat. Yung sequential cohesion. Yan. Number 3, communication cohesion. A module is said to have communication cohesion if all tasks of the module refer to or update the same data structure and the set function defined on an array or a stack. So, ini sa communication cohesion. Siya yung nagko-communicate at sa lahat ng mga tasks sa module para ma-refer to update. Ma-update siya. Parang same lang sa data structure lang. Sa number 4, procedural cohesion. A module is said to be procedural cohesion if the set of purpose of the module are all parts of procedure, in which particular sequence of steps has to carried out of achieving a goal. The algorithm for decoding a message. Yan sa procedural. Ang ibig sabihin yan, siya yung nagdi-decode ng mga pumapasok na message doon sa function cohesion. Sa number 5 naman, temporal cohesion. When a module includes functions that are associated by the fact that all the methods must be executed in the same time, the module is said to be exhibit temporal cohesion. Yeah. Sa number 5 naman, temporal cohesion, siya yung nagtitemporally na mag-execute sa lahat ng mga module. Temporal lang siya. Number 6, logical cohesion. A module is said to be logically cohesive if the elements of the module perform a similar operation. For example, error handling, data input and data output. Yan. Yan yung din lang pumapasok yung date, yung input tsaka output sa logical cohesion. Number 7 naman, coincidental cohesion. So, ano ibig sabihin na a module is said to have coincidental cohesion if it performs a set of tasks that are associated with each other very closely, if at all. Sa coincidental cohesion naman, siya yung nagpe-perform ng task. Bali, siya yung nag-handle lahat ng task. Kasi siya yung pinaka-last. Yan. Yan lang yun sa function sa module cohesion. And then next, coupling. Coupling among modules captures the connectivity of this module. It measures the amount of data, control, or content transfers or passes are made among and between the modules. Thus, we are after low coupling, since it will give the simplest complexity of modules interaction, hence minimize the rippling effect of errors from one module to another. Yan. So, ang ibig sabihin ng coupling, para sa akin, parang siya yung nagbibigay ng mga payo or ano man para ma-minimize yung mga errors mo sa module. Ito yung example ng coupling. So, module coupling in software engineering, the coupling is the degree of interdependence between software modules. Two modules that are tightly coupled are strongly dependent on each other. However, two modules that are closely coupled are not dependent on each other. Uncoupled modules have no independence at all within them. So, ang ibig sabihin ng gantong uncoupled, yung gantong module coupling, pag uncoupled siya, dependence. Pag loosely coupled naman, some dependencies. And then highly coupled, many dependencies. Yan lang yung tatlong example ng module coupling. A good design is the one that has low coupling. Coupling is measured by the number of relation between the modules. That is, the coupling increase at the number of all calls between modules increase or the amount of shared data is large. Yan, dyan nagpo-flow yung data mo. Kunwari, ito, sa PC, PC1, PC2, PC3, PC4. Pagdating dito sa B, magko-connecta na siya. Yan. Pagdating dito sa C, yan, pwede na siya magko-connect, and then may line na siya sa gitna. Pwede mo na siya i-access. Then, ito yung mga types of module coupling. Types of module couplings. There are various types of module coupling are as follows. Yan. Same lang din sa cohesion to. Pero, iba yung presentation niya. So, best, worst, yun yung pinakataas, yung number 1. Number 1, no direct coupling. Number 2, data coupling. 3, stamp coupling. 4, control coupling. 5, external coupling. 6, common coupling. 7, content coupling. So, ano nga ibig sabihin ng mga yan? So, yung sa box na to, bale M1 means module 1. Tapos, nakakonekta siya sa M11. M12. So, M1, M11, M12 nakakonekta. Tapos, merong M2 dito. So, ibig sabihin nito, modules are subordinates to different modules. Therefore, no direct coupling. Hindi siya maka-direct access doon sa M2. Kasi nakakonekta siya sa M11 tsaka M12. Then, number 2, data coupling. When data of one module is passed to another module, this is called data coupling. So, ibig sabihin na M1, Module 1 to Module 11, Module 12, nagpapasa siya ng data. Kasi nakakonekta data variable. Ito yung data, nagpapasa siya. Yan. Yan yung purpose ng data coupling. So, 3, stamp coupling. Two modules are stamp coupled if they communicate using composite data and items such as structure, object, etc. When the module passes non-global data structure or entire structures to another module, they are said to be stamp coupled. For example sa passing structure variable in C or object in C++ language to a module. Yan. Yung sa stamp coupling, siya yung nag-hold. Yan. In itong example, kunwari sa C or object in C++ language, magkapareha siya na C pero magkaiba siya ng meaning. And then, control coupling. Control coupling exists among two modules if data from one module is used to direct the structures of instruction execution in another. Siya yung nagbibigay ng instruction, yung control coupling. Nagbibigay siya ng data instruction doon sa nauna. So, number 5, external coupling. External coupling exists when two modules share in externally imposed data format, communication protocols, or device interface. This is related to communication to external tools and devices. Ibig sabihin na external coupling, siya yung nag-impose ng data. Siya yung naghahawak ng data. And external tools and devices. Nasa kanya lahat ng mga external tools. Ibig sabihin na. Yan yung work ng external coupling. Common coupling. Two modules are common coupled if they share information to some global data items. So, M1, M2, nakakonekta sa global data. So, isi-share niya M1 sa global data, isi-share niya M2 sa global data. Connect lang sila. So, yan yung common coupling. Content coupling. Content coupling exists among two modules if they share code. A branch from one module into another module. Yan. Ang content coupling, siya yung nagsishare ng code sa one module into another module. Siya yung nagbibigay lahat ng code sa coupling. And ito yung tapos na to. Tapos na rin to. Tapos na. And thank you. Salamat po.